Welcome to this video on spot, par and forward yield curves and the relationships between them. It's going to be a really short one. No questions here. Quite theoretical, but utilizing a lot of graphs and drawings and illustrations. So this is going to be unusual because I'm going to be referring quite a lot to the previous recording, which was on par and forward rates, so as to draw your attention to certain, as I said, relationships. Now, it's all about how the different curves fit together and what the relationship between them is. Now, let's, for a start, assume that we have an upward sloping, meaning what is referred to as a normal spot rate curve, or spot curve or yield curve. So basically, if that's on the vertical axis, that's the rate, and that's the time axis, the time to maturity. Remember, spot rates are in fact yield to maturities, YTMs on zero coupon bonds. So if the spot rate curve looks like this, it's upward sloping, spot rates become higher and higher as the time to maturity gets extended. So that's the spot curve. Where will the par curve be in relation to this? Remember, par rates, we discussed this in the previous video, that's the coupon rate or the yield to maturity, which will make the price of a bond equal to 100, equal to par. And let me just go back to the note from the previous lesson. I saved that to be able to show you this. The first question that we did in that previous recording, that previous video, was for a sequence of spot rates, we were asked for the par rate for a bond with 3 years to maturity, and that par rate came in at 8.85%. And there was proof of the fact that this par rate would indeed produce a bond value of 100 of par. Now, please appreciate that the response, that the answer 8.85 was in fact very close to the 3-year spot rate. So 8.85, quite close, but not quite there. Now, the truth about par rates in an upward sloping rate environment, so when the spot rate is going up, the par rate is going to be always slightly behind or slightly lower, but as the time to maturity becomes longer, or as the time horizon becomes longer, that divergence becomes bigger and bigger. So what you need to know is that the par curve in an upward sloping environment, the par curve sits below this spot curve. However, what about the forward yield curve? Well, because of the way forward rates are computed, and we did that in the previous video as well, so I'm going back to that note. We did a lot of forward rate computations, and when the spot curve is upward sloping, like it was here, because we had the yields to maturity on zero coupon bonds, effectively these were spot rates going up like this on a curve, and we computed forward rates. I told you that forward rate kind of has to make up for a shortfall. If you start with an initial relatively low rate in the first year, then to catch up with what would be a higher 2-year rate, a spot rate, you need to make that incremental second year forward rate appropriately higher. So we had 4.34 for the 1 year spot rate, 1 year forward rate in 1 year's time. And then we also computed 4.91 as the 2-year forward rate in 1 year's time. Both of those were definitely higher than the spot rate. So the thing is, with forward rates, you're always, let me use a different color, you're always reaching above the spot curve in an upward sloping environment. They have to be higher to give you an average which is going to be appropriately high. So forward curve, that one sits above the spot curve. Okay, what about in a downward sloping rate environment? So let's draw this. Once again, we've got the rate over here and the time axis over here. And previously we had upward sloping or normal spot curve. Now we're going to have a downward sloping. Downward sloping or inverted spot curve. So let's assume this is the shape of the spot curve going down like this. Where is the power curve going to be? Well, it once again lags the spot curve a little bit, but this time, because the spot curve is dropping, downward sloping, it lags from above. So that's going to be my power curve. Okay, it sits just above the spot curve. However, that difference, this discrepancy gets bigger with the time. So here it was below spot curve, now it's going to be above spot curve, and as you can probably imagine, we didn't do any questions on it, but the forward curve will be even more extreme in terms of its downward slope. So that's going to be our forward curve, and it's going to be below the spot curve this time, below spot curve. Right, so those are the two situations which you kind of really need to know about. There is one more, and that's what happens if you've got a flat spot curve. Obviously, that may happen more or less thereabouts, but never happens completely. But if you have a flat spot curve, that means instead of a curve, you've got a straight line effectively. And it's that one single situation which you may indeed be asked about, where then the power curve is absolutely equal to the spot curve. And for once, it's also equal to the forward curve. So all those curves become straight lines and they line up. Very theoretical, this one, but you know, in the exam it's absolutely possible to get a question like this.